quadratic inequalities objectives. By then, the selection should be able to find a sign chart for the quadratic inequality and solve a quadratic inequality. So what's a quadratic inequality? It's just a quadratic with an equality, as you can see here, right? So greater than, it could be less than, greater than equal to, less than equal to. It's all the same. Now, how do we solve these? We don't solve them like the same way we solve a quadratic equation. Well, for the most part. In a quadratic equation, we're looking for the x-intercepts, right? So if I give you a graph that looks like this, I want to know where f of x equals 0. You're like, oh, where it hits the x-intercepts at? Like a and b, we'll say. But if I want to know where f of x is less than 0, now the x-intercepts have played a big role because that's where it equals 0. So where it's less than 0 is where the graph's below the x-axis in this case. That'll be from here to here. So from A to B. And that's gonna be the difference. When I want to solve an inequality, it should be an interval from where is a below the x-axis or above the x-axis, depending on what I'm asking for. So to do that, we use a sign diagram to help us most of the time. A sign diagram is just a number line that shows you for what values of x is your function positive or negative. Like for this example I drew here, if I was drawing a sign diagram, well, first your horizontal line is just the x-axis, that's all it is. And then you can generally just show the x-intercepts. And for me, based on this graph, right, before A, that'd be a positive sign, because my graph's above the x-axis. Between A and B, that's a negative sign, because your graph's below the x-axis. And after B, positive sign. So it's a little quick sign chart, just so you know, okay, this is where my function is positive, this is where my function is negative. And that's what a sign chart does. A couple things to keep in mind, right? Horizontal line is the x-axis, like I said. Positive, negative values, you generally use plus or minus to show if it's above or below. And zeros are the x-intercepts. So here's a couple examples. So for the function x squared plus x plus 2, x minus 1, you have a graph like this. If I want to turn this into a sign chart, you just go, okay, here's my zeros or my x-intercepts. And then you go down here. I like to circle them personally. So those are my x-intercepts, and then before that, before my negative 2, it's a positive, so plus, and between the negative, so minus, and so right is positive. There we go. On the next one, what's interesting about this one, you have no x-intercepts. So you're either going to be all plus or all minus, because there's no x-intercepts. And this one's above the x-axis, so it's all plus. This one only has one x-intercept at 1. So you circle it. And then they're both negative in this case, so negative, negative. Usually when you only have one x-intercept, it's either going to be both negative or both positive. One thing you might notice if you look at these deeply, when the power is 1 on your answers here and your x-intercepts, then you're going to cross the x-axis. Look at that, x of 2, 1, they only have power 1, you cross them. We call that cutting the x-axis. Some people call it cutting the x-axis. When the power is even, like squared, then you're going to bounce off the x-axis. So look at how it crosses through, cuts through. This one kind of bounces off of it, also known as touching the x-axis. And that's a general thing with all, when you look at x-intercepts and roots and zeros. If it's an odd power, we cross. So if I know something's an odd power, like something like x minus 3 to the 5th, sorry, odd power being this part, then you cross. If it's an even power, like x minus 3 to the 4th, then you're going to bounce off it or touch. So like that. Now this is more helpful if you're actually graphing it, but it does come in handy with the sign chart. Okay, so let's do a couple sign charts, sign diagrams, I guess. So for these two, we can draw a sign diagram for A and B. So first thing I'm going to do is draw my x-axis. There you go. I like to draw where my x-intercepts are. So negative 3 and at 5. And then before negative 3, my graph's below the x-axis, so negative. In between, my graph's above the x-axis, so positive. And then we're negative again. Right, so again, all we're really trying to figure out is this part right here, like the actual graph. Before 3, we're negative. Between 3 and 5, we're positive, we're above it, and then we're negative again. So there's my sign chart. Next one for B, only x-intercept I have is at negative 1. Before negative 1, it's above the x-axis, and after it's also above the x-axis. So there we go. Now we're going to draw a sign diagram for these equations. So step 1 of doing that is set equal to 0. And you want to find the x-intercepts. I mean, that's, well, yeah. Find the x-intercept. So you can do that by factoring or using quadratic formula. So here I'm going to set equal to 0. I'm going to factor for factors. I get x plus 3, x minus 1. It does factor nicely. So you get x equals negative 3 and 1. Now there's generally two ways to draw a sign diagram. Well, how to get there. One is you graph it. So here are my x-intercepts. Now, if you know the graph of this thing, that leads straight into our sign diagram. So how does the graph of this thing look? It goes to positive x squared. So that means that it should be moving up. Again, we're just doing a sketch here, so it looks like this. And there you go. So just from that, I know it's going to be plus, minus, plus. So if I was doing a sign chart, negative 3 and now 1, it's plus, minus, plus. Now that's a good way for you to know how to graph. It's the fastest way for sure. Now if you're not good at graphing, there's actually another way to do it, what we call it using test points. So that way, I'm going to do my little sign chart, negative 3, 1, right there. And what we're going to do is we're going to pick a test point in each of these regions. So something be less than negative 3, negative 4. Something between negative 3 and 1, like 0. And something bigger than 1, which is like 2. And what we're going to do is we're going to plug these test points into the function. So we're going to plug negative 4 into this equation right here. Now, a lot of times it's actually plugged into the factor version of it, but you can plug into any one you want. So negative 4. Let's plug it in. Negative 4 plus 3 times negative 4 minus 1. I get negative 1 times negative 5, which is 5. Notice how 5 is a positive. I don't care what the number is, it's a positive. So this is positive. 0, again, we can plug 0 into here, or we can plug into here. Now, 0 is the one case where I just plug into the original one, because everything kind of goes away and you just get the y-intercept. So for 0, it's going to plug into the original equation, the non-factor version, and I'm going to get negative 3. Oh, so negative. And then 2, likewise, likewise the first time, I'm going to plug 2 into the factor one. It's a little easier. So we'll plug 2 in, I get 2 squared plus 2 times 2 minus 3, and I get 4 plus 4 minus 3, which is 5. Oops. Equals 5. So positive. Again, I don't care what the number is, I care what sign it is. And we get the exact same sign chart. Now again, a little bit more work, but some people would like to do test points instead of just graphing it. So if you're good at graphing, just graph real quick, you got your sign chart. If you don't like graphing, you can do some test points. Now, if you notice with the test points, that's the reason why I circle these things. Because I don't want people to get confused with the test point. Those are not your answers. Your answers are either going to be this or this. Test points are just there. They're just there for test points, for testing points, not for your answer. That's why I circle these. Anyway, let's go to the next one real quick. We'll do this one by graphing again. Now, this one, right, you said equal to 0, find your x-intercepts. There's going to be only one x-intercept. There's it's factored. It's going to be at x equals 3. You could split it. Negative 4 equals 0. X minus 3 squared equals 0. Negative 4 does not equal 0, so that one's done. And then this one, just square root and add 3. So x equals 3 is our only x-intercept. So let's make a sign chart. I'm going to do it at 3. Now again, if you want, you can do a test point, plug a point less than 3 into here, plug a point more than 3 into there. But if you know the graph, this is a negative. Let me erase it so it's my way right now. This is a negative 4 in front. So my A is negative, which means it opens down. So my graph's going to look like this. So my sign chart's going to be negative, negative. And there we go. There's my sign chart. Negative, negative. There we go. Okay. Now that we know how to make a sign chart, either by graphing or by doing test points, let's actually solve some of these things. So how do we solve a quadratic inequality? Well, first, much like we did here, we're going to start the exact same way. We're going to make the right-hand side 0 by shifting all the terms over to the left-hand side. Then we're going to fully factor or use a quadratic formula. Sometimes it's not factorable. You can still do it. Use a quadratic formula. It's totally fine. Then we're going to draw a sign diagram for the left-hand side, and then we're going to determine which values are required for the sign diagram. What do I mean by that? Well, if I want f of x to be less than 0, then I'm looking for the negatives, right? If you want f of x to be greater than 0, then you're looking for the positive values. If they want f of x to equal 0, well, that's those are your x-intercepts. Right, and then since we're doing intervals, if you see less than or equal to, then it should be a bracket. And if you see greater than or equal to, if you see equal to, it's a bracket. If you see less than or greater than, it's a parenthesis. Stuff like that. With the keynote, anytime you do infinity, it's always a parenthesis. So if you have infinity, it's always attached to a parenthesis. Okay, so let's move on. Let's solve for x on this one. So we're going to set equal to 0. So we get 3x squared plus 5x minus 2 equals 0. Now again, you can use the quadratic formula if it factors perfectly. Sorry, you can either factor or you can use the quadratic formula. I believe this one does factor perfectly. I'm going to just do negative 6x squared, right? There's a number in front, so I'm doing this the longer factor. I'm multiplying the outside terms. I get this. Find a combination of those two things. Two things that multiply get negative 6, but add to get positive 5. So that would be positive 6, and negative 1x. Those two things multiply to get negative 6, but add to get positive 5. Now you substitute it in. 3x squared, this stays, minus 2 equals 0, right? So plug it in for 5x, and then I just factor by grouping. These have a 3x in common, x plus 2. Pull that down. You always bring down what they have on the. You always bring down the middle term. These have nothing in common, so we pull out a 1. Remember, negative 2 divided by negative 1 is a positive 2. So we get this. Split it. Sorry, I should mean factor out x plus 2. And now I can split and solve. So each one equal to 0. And we get x equals negative 2. And add 1 divided by 3. 1/3. So I get that. Now again, I'm trying to solve this. So you solve it where it's equal to, but really we're trying to solve greater than. It's actually, right here should be greater than equal to. That was a mistake. I should have corrected earlier. Here we go. So we move it over to the side, then we solve it equal to 0. So there we go. So we're looking for greater than, but to do that I need a sign chart. So let's make a sign chart. So here's my x-intercept. I have negative 2, and I have 1/3. Remember, it's just a thing to help us see what the answer is. It does not have to be perfect. Now, you could do with test points, but I think we're good enough to know that the graph. Look right here, right? Our graph is positive, so it's opening up. So it's look like this, like that. And I want greater than 0, so I'm looking for the positive signs because right we want greater than, so that's positive. So this would be plus, minus, plus. So my answer is going to be this portion and this portion. Now, I just realized one thing we haven't gone over is how to write this as an answer. Well, I want this section. So we're starting off at negative infinity, which is parenthesis, negative infinity. And we're stopping at negative 2. Union, I want this, since I have more than one answer, I want this side too. We're starting at 1/3. And we're ending at infinity. Now, I believe it actually is equal to, so these should be brackets at the two numbers. Remember, infinity is always a parenthesis, but if it's equal to, the numbers right here should be brackets. So these should be brackets. There's my answer. Okay, let's do another one. So same thing here, we're going to set equal to 0. So x squared minus 6x plus 9 is less than 0. And then we just solve it like it's equal to 0. So we factor it. This actually factors up. This is a perfect square. It's x minus 3 times x minus 3. Also known as x minus 3 squared. So x equals 3 is my only x-intercept. If I do a sign chart, 3 is the only place I have. Now, if you forgot the rules of what happens when it's squared, feel free to do test points, right? Plug in a point over here, like 0. If you plug 0 into this thing, you get, right here, sorry, you get 9, so positive. Plug something bigger, like 4 on this side, plug 4 into here, and you get 1, positive. So it still works that way too. But if you remember the graph, when it's squared, it bounces. It should like touch your graph and go up. And it's positive because it's a positive x squared. I hate when that happens. There we go. So it's something like this. Like that. I want less than 0. This graph is never less than 0, so there's no solution. Now, if I want it equal to 0, it would be equal to 0 at 3. Greater than 0 would be from negative infinity to 3, 3 to infinity. But less than 0, graph is never less than 0. So there we go with that one. Okay, let's do one more. Find the values of k for which y equals kx squared plus k plus 3 times x minus 1 cuts the x-axis twice, touches the x-axis, or misses the x-axis. So seeing this type of question hopefully puts some light bulbs in your head. What are they talking about? They're talking about the discriminant. So b squared minus 4ac. If you remember the discriminant, it says when the discriminant is greater than 0, you have two real solutions, also known as you cut the x-axis twice. When it equals 0, you have one real solution, also known as touching the x-axis. And then when it's less than 0, you don't cross x-axis at all, so you miss the x-axis. You have no x-intercepts. You have no real solutions. So like that. So that's all this is. This is a fancy way of saying use your discriminant to figure out, to solve this question, basically. So we're just going to do the first one because it's all the same after that. So we want to find out when this thing cuts the x-axis twice. So let's just use the discriminant. We have the formula right here, right? We know the triangle. The discriminant should be greater than 0. The discriminant is b squared minus 4ac. I know that should be greater than 0. Well, what is ABC? A is a coefficient of x squared, so just k. B is a coefficient of x, so k plus 3. And then c is a constant term. So we're going to type that, plug that all in here. K plus 3 squared minus 4 times a, which is k, times c, which is negative 1. I want that to be greater than 0 because we want to cut the x-axis twice. So we just got to solve this. Keep in mind this right here, do not be lazy. That is k plus 3 times k plus 3. And then over here I get double negative, so plus 4k. And I want this to be greater than 0. So distribute, I get k squared plus 6k plus 9 plus 4k greater than 0. Right, this is k squared plus 3k plus 3k plus 9. I just added the middle terms already to get 6k. Out of like terms, I get k squared plus 10k plus 9 is greater than 0. So now here I just got a factor, or quadratic formula if you must. I need two things that multiply to get 9, but add to get 10, so it's 9 and 1. K plus 9, k plus 1 is greater than 0. Now remember, the way we solve an inequality, because it's quadratic, is we actually set it equal to 0, and then we graph it, or do a sign chart. I mean, do a sign chart, but either graph it or use test points. So my x-intercepts are negative 1 and negative 9. Let's do one. So I'll just do it on the side here. Here's my sign chart. Keep in mind, negative 9 comes first. Negative 9 is smaller than negative 1. Negative 1 comes here. Now again, if you want, you can do test points. Pick some points in each of these intervals and plug it into either our original equation right here, like this guy, or into the factored form. Or if you know the graph, right? We're just trying to graph. All we're trying to do is graph this guy. Well, that's a positive x squared, so it opens up. So it's something like this. Which means we have plus, minus, plus. What are we looking for? We're looking for plus again, positive. So we want this side and this side again. And this side, no equal to sign, so all parentheses. So we want negative infinity to negative 9, union negative 1 to infinity. And there we go. Since I'm here, if I wanted to solve this one, well, where does it equal 0? We just solve that right there. This is where k equals negative 1 and negative 9. Where's it less than 0? It's the exact same picture. So where's my function less than 0? In between, from negative 9 to negative 1. And those are your answers. And that's the lesson.